I just found something interesting out by the curb, and no, it's not a musical instrument, it is a TI-83 graphing calculator. Seeing this immediately brings back memories of my high school math class, although I think mine was a TI-82. So the reason we're talking about this, the reason the camera is on right now, is the first thing I did when I got home with the calculator was to search on the internet and see if there wasn't some way of making music with a graphing calculator. And you know what? There is. An artist named Erlicht Project has written a piece of software called Houston Tracker that actually allows you to use one of these to write music. And that's what I'm going to try to do today. So in order to install the software on my calculator, I need to use this special USB cable. Okay, I'm just going to say it. Installing Houston Tracker on this little calculator was miserable. It took me over 6 hours. I went through 4 different computers, 3 Windows machines, and 1 Mac. In the end, the only thing that worked was this one random Mac from 2009, a Mac that, coincidentally, I also found out by the curb and that I've been saving for a completely different project. Just look at that progress bar. After all my struggles, that is just a real thing of beauty. Okay, it's time. Let's dig in and try to make some music. So once it's on, we press Apps, and you'll notice that Houston Tracker isn't actually listed as one of the installed apps. We need to run this other program called Doors CS, and from there we can launch Houston Tracker. This is the main screen, and for people who have used LSDJ on the Game Boy, this will look very familiar. So Houston Tracker is actually very well documented. To get started, I'm just going to follow the quick tutorial that's in the manual. Each of these columns corresponds to a different channel, and each of these numbers corresponds to a different musical pattern. Of course, all these patterns are blank right now. It's up to us to fill them in. To do that, we make use of the letter buttons. Ooh, I heard something. I think this note is too low. Let's make the next one an octave above. According to the manual, we can change octaves by pressing this button. And now I just make my way through the grid, adding any notes that I want. This is the bass pattern I ended up with. I honestly can't believe this thing is working at all. Okay, let's add in another layer. I'm deliberately adding in notes that are an octave above so they don't clash with what I've already put in. Here's both layers together. Next, I'm going to add a lead melody and percussion. Yes, this thing even has extremely primitive percussion. So folks who are familiar with TI graphing calculators might be wondering, what sorcery is this? These calculators don't have speakers, they don't have headphone jacks, they don't even have any kind of sound chip or facility for producing sound. How is this possibly working? Well, the one thing that they do have is a data port. So you've probably heard that computers use ones and zeros to communicate. Well, that's how the data port works as well. It can send 2 different voltages, high and low. Those get understood by other calculators or computers as either 1 or 0. Well, if you send a bunch of zeros, then a bunch of ones, then a bunch of zeros, and keep going like that, you will have eventually produced an audible sound, a square wave. So that's what this software is doing. It's basically misusing the data port, sending ones and zeros. They're coming out of this cable and out to my speakers, and our ears are hearing it as a square wave. It's pretty clever. Coming back to that little piece of music we were working on, here's what the percussion sounds like. Yeah, pretty abrasive. And because we're working with 1-bit audio, there's no way to turn it down relative to the other instruments. Here's the whole thing all together. All in all, as lo-fi as this sounds, it's pretty amazing that it works. I remember when I got the TI-82, I was so excited. As a kid, I never had a Game Boy or any console at home, so this was kind of like as close as I was going to get. But then when I had it, I didn't feel like I really used most of its potential. Occasionally, I would graph a function in class, but mostly it just sat on my desk and made me feel like I was doing math. Look at that beautiful sine wave. If only we could hear it. Actually, when I first looked up whether or not it was possible to make music on a graphing calculator, this is kind of what I imagined. I thought maybe it would be possible to type in a waveform and then play the sound produced by that waveform graph. Obviously, a graphing calculator is not really up to that task, but I'm going to look into whether or not it might be possible to build something like that on the computer, because I think that would be pretty cool. Okay, I just spent 3 hours hacking at this, and I now have a prototype. Right now, it's just playing a sine wave. But I can type in a new equation in this little box. The graph will pop up, and then I can use that waveform as my new sound. Obviously, this is super basic, but it's also like exactly what I wanted. I'm also finding out that trying out different equations is incredibly addictive. I spend several hours just typing different equations into the box. Okay, enough of that. I'm going to try to add some more controls to this. Okay, so I'm back with another prototype. It's pretty much the same as before, but now you can add your own parameters into the mix. So here we've got an equation that has variables a and b in it, and we can change the values of a and b using these sliders. I've also added these x and y scale controls that compress the graph horizontally or vertically. So one thing that I've noticed from playing with this, on a digital synth, a waveform is usually defined as being between a fixed range, like between -1 and 1, something like that. Well, that works really well for something like a sine wave, which stays within those limits, but some functions exceed those ranges. For example, with this equation, those spikes go all the way to positive or negative infinity. To prevent things from becoming ear-shatteringly loud, this plugin clips really loud signals. You see how the lines don't go all the way up. Of course, that intentional clipping then becomes part of the sound of the plugin. Anyway, I've never really seen a synthesizer like this before, so I'm thinking maybe it'll be worth it for me to try to turn this into a real product. Okay, so many months have passed since my original prototype, and it now feels more like a real product. I spent several days painstakingly recreating the LCD screen of my graphing calculator. I think it looks pretty close to the original now. Okay, so what have we got here? Well, in addition to the graphing functionality, there's pretty much everything you'd expect from a standard synthesizer plugin. There's a full modulation matrix, 3 LFOs, 3 envelopes. Any of the parameters that are used in your equations can be modulated, which I think is really cool. There's MPE support, and then on top of that, there are onboard effects, delay, chorus, reverb, and my personal favorite, the tape simulator. Building your own equations and presets, I think, is really fun. Of course, I know not everyone is going to feel comfortable with that kind of math, so it also includes 100 presets. These span all sorts of genres, so there should be something for everyone. All in all, I'm really proud of this thing. It sounds cool and it's weirdly educational. For example, I'd never seen what a waveform actually looks like when it's being filtered, or seen what it looks like when you add noise to a signal. This beautiful plugin, which I've been working on for so long, is now on sale for the modest price of $29. So if this plugin excites you, if you feel like you're ready to dive into the world of graphing calculator synthesis, now is a great time to pick this up. It's funny, I think of myself as a pretty sober person, a man of science, if you will, and yet I'll often let these little experiences, things like finding a calculator in the trash, dictate how I spend large chunks of my time. I really do feel like it's a sign when I find something, and this has been quite a journey. Anyway, I'm really happy that I let this little machine be my inspiration for this project. I'm really happy with the result. Okay, I think that's it. Happy holidays and see you soon.